This is Unit 12, Electrochemistry, Lesson 1, Oxidation Numbers. How is the oxidation number of atoms and ions determined? The objectives of this lesson: I can determine the oxidation number of atoms and ions in a chemical reaction. Do now. So I wonder, what is electricity and how is it formed? Throughout this unit, we'll learn about this. But for now, we're going to just talk about in electrochemical reactions, electrons are transferred from one species to another. So that's how we get electricity. In order to keep track of what loses electrons and what gains them, we assign oxidation numbers. So that's where we get those selected oxidation states from our elements on periodic table, and this will be part of how we use that. So there are 7 rules for assigning oxidation numbers. 1. Any uncombined elements, not combined with any other element, have an oxidation number of 0, and this includes diatomic elements. So for example, in this formula where I add sodium and chlorine together to produce sodium chloride, both sodium and chlorine have an oxidation state of 0. Number 2, if an element has only one charge listed on the periodic table, then that's its oxidation state. So for example, group 1 and group 2 are always positive 1 for group 1 and positive 2 for group 2. And we can see that here on our periodic table, all of those elements have only one oxidation number. 3, in a compound, the atom listed last must be a negative charge. So this is really important here. We've talked a lot about this before when we make compounds. So for example, when I put sodium and chloride together, even though chlorine has these positive oxidation states, when I write it last, it will be that negative. Number 4, H is usually +1 in the front and -1 in the back. So for example, if I have H3P, P is a -3 and each of those hydrogens is a +1. However, if I put lithium hydride together, then the lithium must be +1 because it's a group 1. Therefore, H is going to be that -1. 5, the sum of the oxidation numbers in a compound must equal 0. So for example, calcium chloride, when I put those two elements together, the sums of them will be 0. So calcium, because it's in group 2, will have a positive 2 charge. Chlorine, because it's written at the back, it will be that negative state. I have 2 chlorines here, so +1 times 1 calcium minus -1 times 2 will equal 0. So be sure to multiply the oxidation number by the number of atoms indicated by the subscript. Step 6, or rule 6, if an element has more than one charge listed, use the other charges to figure it out. So for example, some of our transition metals have multiple oxidation states. So first, assign the oxidation number to the elements with one oxidation number. So for example, when I have iron chloride here, we know chlorine will be -1 because it's at the back. It will be that -1 charge. I have 3 of those. So together, they have to add up to be 0. So because I have a -3 and iron has the choice of a +3, +3 and -3 will make a sum of 0. Rule 7, the sum of the oxidation numbers in an ion must equal the charge of the ion listed. So for example, chromate from table E has an oxidation state of -2. Therefore, the sums of those oxidation states will add up to be -2. So chromium has multiple choices. So what we have to do is use oxygens, which is almost always a -2. There are 7 oxygens, so 7 times -2 makes -14. Therefore, to get a sum of -2, we have to have a +12 charge. So that means the chromium must be 6. So 6 times 2 will get 12. And carbonate has a -2 charge. O is -2, but there are 3, so we have a total of -6. To have 2 left over, carbon must be a +4. Therefore, the sum of this will equal -2. So in polyatomic ions, the first and the middle atoms always have a plus oxidation state. So there are a couple of exceptions. Oxygen is -2, except when it's bonded to fluorine. When it's bonded to fluorine, then it will be a +2. And then oxygen is -1 in peroxide. So if you look on table E, you'll see a peroxide is an O2 with a -2 charge. In order for us to have two oxygens together, we'll have to have a -1 charge. So we're going to have to be careful when we look at some of our formulas. Peroxide will make -1 for our oxidation state in a peroxide because each potassium has a +1 charge, and there are two oxygens, so each one has to be a -1. So for example, I'll walk you through some of these with our rules. Determine the oxidation number of each atom. Remember, if an element by itself has an oxidation number of 0, and that includes diatomics. If I have a charge listed, the oxidation state will be that charge. In compounds, the sum of my elements, the oxidation states must be 0. So lithium is in group 1, so it's always a +1. Therefore, fluorine is a -1. And so NaBro, sodium bromate, my oxygen will be a -2. I have 3 of them, so I'll have a -6. Sodium is going to be a +1. Therefore, to make my -6 equal, my bromine has to be a +5. Magnesium, oxygen is always a -2. I have 4 of them, therefore that's a -8. Magnesium is always a +2. In order to get a sum of 0, my sulfur has to be a +6. So my +8 and my -8 will equal 0. Potassium chlorate, -2 times 4 will get me a -8. Potassium is a +1, therefore chlorine must be a +7. So check your understanding. And now I can determine the oxidation number of atoms and ions in a chemical reaction.